Hey everyone, so in this video we're going to be discussing two-sided continuity and how to further explain whether a specific function is continuous or not and defining continuity further. So another way of explaining continuity is when the limit of f of x as x approaches c is equivalent to the limit of f of x as x approaches c from the negative side, and when that's also equal to the limit of f of x as x approaches c from the positive side, and if that also equals the value of f of c. Basically, to break this down into simpler terms, the function is continuous at x equals c when the limit is equal to the y value at c, aka f of c. But sometimes to better understand the limit of a function at x equals c or at a specific x value, you have to look at the one-sided limits. Let's discuss the continuity of the following functions. So as we can see in the first following example, we have this piecewise function. So right off the bat, we can see that the only x value to really question here is what's going on at x equals 1 at f of x. So to discuss continuity in functions, like the previous slide, we have to explain why the function is continuous and why it isn't. So to actually see what's going on at x equals 1, let's actually look at the one-sided limits. So the limit of f of x as x is approaching 1 from the negative side, such as from 0 or negative 1, etc., is 3. And that's also equivalent to f of 1. Now, to actually find these one-sided limits, you would just plug in a value smaller than 1 in this example, since we're approaching f of x as x approaches 1 from the negative side. The same kind of idea goes for the limit of f of x as x approaches 1 from the positive side, which we can see is also 3. So therefore, since the one-sided limits are equivalent to each other, we can see that the limit of f of x as x approaches 1 is 3. And that's also equal to the value of f of 1, which is also 3. So since this is given, we can see that f of x is therefore continuous everywhere for all real numbers. Now let's look at our second example. As you can see, that is the graph of that following piecewise function. As you can see, the function is continuous throughout. Now let's look at this following piecewise function, and same idea. The only x value to really question here is 1. We have to kind of see what's going on at f of x at x equals 1. So we look at the one-sided limits, and okay, we can see that the limit of f of x as x approaches 1 from the negative side is equivalent to f of 1. Okay, now let's look at the other one-sided limit, and we can see that these limits do not equal each other. So therefore, since the one-sided limits don't equal each other, the limit as x approaches 1 of f of x does not exist because the one-sided limits are not equal. So f of x is therefore just not continuous. And as you can see in the graph, clearly the one-sided limits are approaching different y values as x approaches 1. I hope this video helped. Comment down below any other math topics you want me to review. Thank you.